In this slide, I have explained about the divisions of the gut tube. As you know, in the general embryology, there is three important layers: ectoderm, mesoderm, and endoderm. Okay. In these pictures, you can see ectoderm, mesoderm, and endoderm. Endoderm with yellow color. Okay. After the folding in the embryo, or after the cephalocaudal and lateral folding in the embryo, endoderm also folds and finally gives rise to primitive gut. In this picture, you can see the primitive gut. Primitive gut, in fact, divides to three parts: foregut, midgut, and hindgut. In this picture, you can see foregut, midgut, and hindgut. Okay? In this picture, you can see again the primitive gut. As you see in this picture, midgut connects to yolk sac by vitellian duct or yolk sac. Midgut is here, vitellian duct is here, and yolk sac is here. Okay? But the sections of primitive gut or gut tube consist of pharyngeal gut, foregut or proper foregut, midgut, and hindgut. Okay? Pharyngeal gut extends from oropharyngeal membrane to respiratory bud or respiratory diverticulum. Proper foregut starts from respiratory diverticulum and ends to liver bud. Okay? Midgut. Please tell me the start point of midgut.
Liver bud.
And the end point?
Transverse
Junction between right 2/3 and left 1/3 of transverse mesocolon. Okay? Colon, transverse colon. And the hindgut extends from left 1/3 of transverse colon to colon. Okay? Foregut gives rise to esophagus, stomach, liver, gallbladder, and the first part of the duodenum. Okay? And midgut gives rise to the remaining part of duodenum and jejunum and ileum and cecum, appendix, and ascending colon, and right 2/3 of transverse colon. Okay? And hindgut gives rise to left 1/3 of transverse mesocolon and descending colon, sigmoid colon, and rectum, and upper part of anal canal. Okay? The origin of gut tube, or does the digestive system have only one origin? No. As you know, the digestive system consists of two important parts: digestive tract and digestive glands. Okay? As you study, the digestive system has three layers: epithelial layer, muscular layer, and connective tissue. Connective tissue or serous or adventice. Okay? Epithelium layer of digestive tract and parenchyma of glands are originated from endoderm. Okay? But tract are originated from visceral mesoderm. Look at this picture. In this picture, you can see ectoderm layer, parietal mesoderm, and visceral mesoderm. Okay? And what is this? Endoderm layer. In this picture, you can see gut tube or digestive tract. Please tell me the origin of epithelial layer as a inner layer of
Endoderm.
digestive tract.
Endoderm.
Okay? And muscular layer and connective and peritoneal layer of is
Visceral.
originated from
Visceral mesoderm.
mesoderm. This is visceral mesoderm. Visceral mesoderm. Please tell me the origin. Dorsal mesentery. What? This is dorsal mesentery. Dorsal mesentery is located between posterior abdominal wall and digestive tract. Okay? It's originated from visceral and parietal mesoderm. This is the junction site of parietal and visceral mesoderm. But ventral mesoderm is originated from mesoderm of transverse septum. Septum transversum. Okay? Between stomach and duodenum and liver. Okay? Lesser omentum is here, greater omentum is here. But in this session, I would like to explain about the development of peritoneum, visceral and parietal. Okay? Again, you can see in these pictures. What is this? Ectoderm layer. And this is visceral mesoderm. Parietal mesoderm is here and visceral mesoderm is here. And what is this? Endoderm layer. Okay? Please look at this picture and tell me the origin of visceral peritoneum. This is visceral peritoneum and this is parietal peritoneum. Please tell me the origin of visceral peritoneum. Visceral peritoneum is originated from visceral mesoderm. And parietal peritoneum is originated from parietal mesoderm. Okay? Please match two pictures. What is this?
Visceral mesoderm.
And this is?
Parietal mesoderm.
In this picture, you can see visceral peritoneum and parietal peritoneum. Okay? Please tell me the origin of parietal peritoneum.
Parietal mesoderm.
And visceral peritoneum is
Visceral
originated from?
visceral mesoderm.
In this picture, you can see a sagittal section of embryo. In this picture, you can see digestive gut, okay, or gut tube. Foregut, midgut, and hindgut, okay. Please look at this part. This part is called dorsal mesentery. Dorsal mesentery. As you see, dorsal mesentery is located between posterior wall of abdomen, and gut tube. Okay. Dorsal mesentery extends from lower part of esophagus to rectum. Okay. extends from lower part of esophagus and to
Rectum.
rectum. As you see, dorsal mesentery is a pathway for passing of vessels and lymphatic and nerves. Look at this picture. Celiac artery, superior mesenteric artery, and inferior mesenteric artery that pass inside the dorsal mesentery. Okay? But at first there is a general dorsal mesentery. General dorsal mesentery. But in the next steps, according to the name of organs, dorsal mesentery is renamed. For example, mesoduodenum, mesogastric, mesocolon, mesoappendix, mesosigmoid. Mesosigmoid means the dorsal mesentery around the sigmoid colon. Mesocolon covers the transverse colon. Mesoappendix belongs to appendix organ. Okay? Mesentery proper belongs to a small intestine, or mesentery proper covers the loops of a small intestine. Okay? So you can see in this picture dorsal mesogastric, mesoduodenum, proper mesentery, mesosigmoid, mesocolon. Okay? Understand?
Yes.
Any question?
No.
Mesentery. So far, I have explained about the dorsal mesentery, and now I explain about the ventral mesentery. Okay? As you see in this picture, this is
Dorsal.
digestive tract or gut tube, and this is
Dorsal.
dorsal mesentery. Okay? Ventral mesentery is here. At first, ventral mesentery is located between a part of gut tube and anterior wall of abdomen. In fact, ventral mesentery is located between stomach and first part of duodenum and anterior wall of abdomen. Okay? Ventral mesentery extends from stomach and to first part of the duodenum. Just. What is the origin of dorsal mesentery? Dorsal mesentery?
Posterior.
Oh, this is the origin, embryologically, origin of the posterior mesentery. Posterior mesentery is originated from mesoderm. Okay? Please, again look at this picture. This is gut tube. Okay? And this is dorsal mesentery. Dorsal mesentery is originated from parietal and visceral mesoderm. Okay? No? Yes? But mesentery, ventral mesentery, is originated from mesoderm of transverse septum. What is this septum transversum or transverse septum? Transverse septum is a mesodermal plate that is located between pericardial cavity and urethra and Viterian duct. At first, please see in this picture. In this picture, you can see a sagittal section of embryo. Okay, this is gut tube, this is Viterian duct, and urethra is here. This is pericardial cavity. This is septum transversum. Septum transversum, as a mesodermal plate, is located between pericardial cavity and Viterian duct or urethra. Okay. Ventral mesentery is originated from mesodermal septum transversum. In the other word, the mesoderm of septum transversum is origin for ventral mesentery. Okay. At the first step, there is a intact or integrate ventral mesoderm. But the next step, liver bud grooves inside the ventral mesentery. This is liver bud. Okay, liver bud starts to groove inside the ventral mesentery. So, by this way, ventral mesentery divides two parts. First and second parts. Okay? Ventral mesentery divides two parts. Falciform ligament, and lesser omentum. Do you know falciform ligament? Falciform ligament connects liver to anterior abdominal wall. This is liver. Anterior surface of liver is here. Anterior wall of abdomen is here. So, falciform ligament is located between two organs. Okay?
Yes.
Lesser omentum. What is the lesser omentum? Lesser omentum is a part of peritoneum that is located between stomach and first part of the duodenum and liver. Okay? Stomach is here, first part of the duodenum is here, and liver is here. Okay? Between three organs: stomach, first part of the duodenum, and liver. Anatomically, lesser omentum is here. What is this?
Stomach.
And this is first part of, and this is liver. Okay? Lesser omentum anatomically is located between three organs. What is the origin of lesser omentum? Mesoderm of
Septum transversum.
The origin of ventral mesentery and falciform ligament and lesser omentum are similar. Okay? In this picture, you can see again stomach, liver bud, first part of the duodenum, and septum transversum, falciform ligament, liver, lesser omentum is here. Okay? Finally, lesser omentum divides two ligaments. Please tell me the name of ligaments. Hepatogastric and hepatoduodenal. Hepatogastric and hepatoduodenal. In fact, the lesser omentum consists of two ligaments: hepatoduodenal and hepatogastric. Okay? So, Please tell me the origin of hepatogastric ligament. Mesoderm, septum transversum. Mesoderm of septum transversum. What is the origin of hepatoduodenal ligament? Mesoderm of septum transversum. Okay. In this slide, I'm gonna explain about the development of esophagus. Please carefully look at this picture. In this picture, you can see gut tube or foregut, and this is respiratory bud or respiratory diverticle. In the fourth week, respiratory diverticulum is appeared from anterior wall of foregut. Okay, this is foregut, this is anterior part or anterior wall of foregut, and this is respiratory diverticulum. In the fourth week, respiratory diverticulum is appeared from the anterior wall of foregut. Okay, the next step, a septum that is called esophagotracheal septum is appeared. The next step is septum that is called esophagotracheal septum is appeared. The final stage, gut tube or foregut divides two parts, anterior part and posterior part. Anterior part or respiratory tract or respiratory system, and posterior part or esophagus. Esophagus. This is esophagus and this is trachea. Anatomically, as you know, trachea is located anterior to esophagus. Okay? In this picture, you can see the development of esophagus. What is the origin of esophagus? Foregut. Okay? As you know, esophagus has many layers from inner to outer. Epithelial layer, muscular layer, and adventice. Okay? Just epithelium layer of esophagus is originated from endoderm, but muscular layer and adventice or connective tissue of esophagus are originated from mesoderm. Okay? Visceral mesoderm. Okay? First, the length of esophagus is short, but during the ascent of heart and lungs, the length of esophagus is long. Okay? Clinically, there is a pathological or abnormal condition that is called esophageal atresia or tracheoesophageal fistula. Okay? In this picture, you can see the kinds of esophageal atresia or fistula. For example, in this picture, in this part, you can see trachea and two bronchus, and this is esophagus. But the proximal end and distal end of esophagus are blinded. Okay? Or in this picture, you can see a proximal part of esophagus that connects to trachea by a tracheoesophageal fistula. But the distal end of esophagus is blinded. Okay? Or please tell me the position of this pathological condition. Proximal end is blinded and distal end connects to trachea by fistula. Okay? This type is most common abnormality. This kind or A figure is common most abnormality. Okay? Also, there is another pathological condition that is called congenital hiatal hernia. Congenital hiatal hernia. In this condition, elongation of esophagus is failed. So, stomach remains in the thoracic cavity and press the lungs and leads to hypoplasia of lungs. Okay? As you see in this picture, a part of the stomach remains in the thoracic cavity, and this condition may lead to hypoplasia of lungs, okay, and leads to respiratory distress, okay. Congenital hiatal hernia. Development of stomach. Development of stomach. Fourthly, a part of foregut expands and forms stomach. In the fourth week, a part of foregut expands and forms stomach. In the other one, a stomach as a fusiform dilation is appeared from foregut. Okay? But the next step, a stomach must rotate. Must rotate. A stomach rotates around two axes, longitudinal axis and anterior posterior axis. Okay, this is fusiform dilation or stomach at the first step. And the next steps, a stomach must rotate around two axes, longitudinal axis and anterior posterior axis. Okay. A stomach rotates around the longitudinal axis 90-degree clockwise. Okay. This is a stomach, fusiform shape. Okay. Longitudinal axis is here. Rotate 90 degrees clockwise around the longitudinal axis, okay? Clockwise. As a result of this rotation, anterior surface is moved to right side. Okay? Anterior surface is moved to and posterior surface. Okay. Right border or right side of stomach is moved to posterior. Okay? And left side is moved to anterior. Okay? So as a result of this rotation, left side is moved to anterior and right side is moved to posterior. Also, left vagus nerve innervates anterior surface and right vagus nerve narrates posterior surface. Anatomically, as you study, right vagus is located the posterior part of esophagus and left vagus is located the anterior part of esophagus. Okay? Stomach rotates 90 degrees likewise around its longitudinal axis. As a result of this rotation, left side is moved anteriorly, and left vagus nerve innervates the anterior part of stomach. Okay? Also, posterior wall of stomach grows faster than the anterior surface or anterior part. Posterior part is here, anterior is here. Posterior part or wall of stomach grows faster than the anterior wall. So, this manner leads to the formation of greater curvature and lesser curvature. Okay? Greater curvature is here and lesser is here. Okay? In this slide, you can see the longitudinal rotation of stomach and formation of greater curvature, lesser curvature, and the movement of vagus nerve, left and right. Okay? Right vagus nerve is here, left is here. After rotation, finally you can see left vagus nerve in the anterior surface and right vagus nerve in the posterior surface. Okay? Again, in this picture you can see the longitudinal rotation of the stomach. In this section, you can see stomach, dorsal mesentery or dorsal mesogaster, and ventral mesentery or lesser omentum. Lesser omentum is located between stomach and liver. Okay? Lesser omentum is located the anterior part of stomach, and dorsal mesogaster is located behind the stomach. Okay? After longitudinal rotation of stomach, dorsal mesentery pulls to left or posterior part. Dorsal mesentery or mesogaster pulls to the left part, and ventral mesogaster or lesser omentum pulls to the right side. Okay? Ventral or lesser omentum is here and dorsal mesogaster is here. After longitudinal rotation, dorsal mesogaster pulls to left side and lesser omentum or ventral mesogaster pulls to right side. Okay? As a result of this rotation, formation of bursa omentalis space or lesser sac. As you know, in the abdominal cavity, there are two sacs, greater sac and lesser sac. Lesser sac or bursa omentalis. Lesser sac or bursa omentalis is located behind the stomach. Behind the stomach. Okay? The formation of bursa omentalis is formed by the longitudinal rotation of the stomach. Okay? In this picture, you can see again the longitudinal rotation of the stomach. This is the stomach. And this is rotation, longitudinal rotation. Bursa omentalis forms behind the stomach. Bursa omentalis is here. Okay? So far, I have explained about the longitudinal rotation of the stomach. Now, I explain about the anterior posterior rotation of the stomach. Antero-posterior rotation of the stomach. Okay? Shall I continue?
Yes, ma'am.
Yes? I have explained about the longitudinal rotation of the stomach and outcome of this rotation. Now I would like to explain about the antero-posterior rotation of the stomach. The stomach rotates around the antero-posterior axis. This rotation leads to the movement of caudal or pyloric part of the stomach to right and upward. As you know, just a moment. As you know, a stomach has three parts: fundus, body. And pyloric part. Okay, pyloric part is here. Cardiac part is here. Okay. After this rotation, the caudal or pyloric part moves to right and upward, right and upward, and cardiac or cephalic part of stomach moves to left and downward. Okay. Also, this rotation leads to the formation of greater omentum. In the other word, the antero-posterior rotation of the stomach leads to the formation of greater omentum. As I said, greater omentum hangs from greater curvature of a stomach and puts on the loops of the small intestine. Okay? In the other word, after this rotation, dorsal mesogaster bulges to down and finally forms greater omentum. Greater omentum as a operon is a double layer of peritoneum. After the antero-posterior rotation of the stomach, dorsal mesogaster bulge to the down. Okay? Bulge to the down and finally forms greater omentum. Greater omentum is a double layer of peritoneum that hangs from greater curvature of stomach. Okay, as you see in this picture. In these pictures, you can see again the stomach and greater omentum. Greater omentum anatomically in the outer body is here. Greater omentum is a part of peritoneum and puts on the loops of a small intestine. Okay? In fact, after the removal of greater omentum, you can see the loops of a small intestine. Okay? You can see a sagittal section of abdomen. Stomach is here. Mesocolon mesentery is here. And finally, in this picture, you can see greater omentum. Okay? Clinically, there is a abnormal or pathological condition that is called Pillory Stenosis. Pillory Stenosis. This condition is characterized by hypertrophy of circular muscle of the stomach, extreme narrowing of the pyloric lumen, and projectile vomiting. Okay? Please attention to this sentence. Treatment with erythromycin in the newborn period may increase the risk for the pyloric stenosis. Okay? Pyloric stenosis is here. The circular muscle of stomach is hypertrophy. Okay?